So, just a reminder about what we've covered so far. We introduced variables. So we started talking about algebra and we've introduced variables. And we said that the whole point of variables is because in math, in the real world, we have what we call variable scenarios or changing scenarios. And we need numbers that can change. And that's what variables are, okay? So we can change the value of a variable. The cool thing about it though is we can write equations in general. So for example, how we wrote this one, we wrote 25b and 2x. We're saying the way we're charging people stays the same, so we're being fair to everyone, but the actual prices change depending on what someone orders from my business or what the scenario is. The whole point is that in the real world things are changing. Does everybody agree with that? Yeah? So now we know generally why we have algebra. The next thing to do is to start talking about how do we actually work with these numbers. How can we add them together? How can we multiply them together? Stuff like that, okay? So let's start there. So we want to know how to do operations on variables. And the first thing we want to talk about, when you guys were in kindergarten and you started learning about numbers, what was the first thing they taught you to do? What do you think? Adding and subtracting. The first thing you would have learned to do with numbers is just how to add them and subtract them from each other. They taught you how to count with your fingers. Exactly right. We're going to do the exact same thing with algebraic terms and variables. So the first thing we want to know is how do we add and subtract variables? When we add variables together, when adding variables together, we want to think about how many total of that variable we have. It's good to think of variables as quote-unquote things. So just think of variables as things and it'll help you understand a lot better. So I'll show you an example of what I mean by that. Let's do an example of representing, so everyone from the previous examples we've done understands that variables can just represent like items. Like for example, when we were talking about like the number of cake layers, for example, we gave it a variable name. We said L, right? Let's do an example with pens. So here I have a bunch of the same pen. They're all different colors, but it's like the same style of pen, right? Let's say that I give Sophia X pens. I've given you 2p. So you now have 2p in your hand. Agreed? Bilal, I'm going to give you 3p. Okay? And then Joseph, I'm going to give you 2p. So now Sophia has 2p. Does everyone agree with that? Guys, stop clicking my pens. So Sophia has 2p. Then Bilal has 3p. And Joseph, you have 2p, right?
Yep.
Cool.
Where'd you get this?
America. Target. My brother went to America recently. They're nice pens. And then I just have p. I just have 1p, which I'm just going to call p. I just have pen. I don't have 2 pen. Do I need to say I have 1 pen? Doesn't it make sense for me to just say I have a pen? Do I need to say I have a 1 pen?
No, you say I have
A pen.
1 pen.
But do I need to say that? Can't I just say I have a pen?
Yeah.
Doesn't that mean I have 1 pen?
Well, what if you say I have a pens?
I have a pens doesn't make sense because how do I know how many pens you have?
That's true.
You can say I have pens, but you're not giving me any information about how much you have. So me, I have 1 pen. So Marianne, I can just write p. So this is a thing in math, guys. When you only have one of a variable, you don't need to write 1 in front of it. You can just say p, and that stands for 1p. Is everybody cool with that?
Yeah.
Now, let's say how many pens, how many p do we have in total? Can someone look there and just using your normal addition knowledge, how many pens do we have in total? Anyone?
8, sorry.
Yeah, 8 total pens. So there's 8 total pens. So all we did, please pay attention to this. Do we change the letter P? No, because we're still just adding together the pens. Do we make it pens squared? Do we make it pens to the power of 8? No. We're just talking about pens. Does everybody agree with that? Yeah? So we have 8 pens in total. Is everybody cool with this? Now, 8 pens in total. What did we do? Can someone tell me what did we do mathematically? How did we add it together? Now, can someone tell me mathematically what did we do? How did we get the 8p? What did we do?
Add all of them.
Add all of them. And you agree that we count this p as 1 extra, right? So we have like 5 plus 2, which is 7, and then plus 1 extra, which is 8p. Is everyone cool with that? So, to add variables, all you do is you just add the numbers in front of the variables. And does everyone understand why from my pen example we do that? Everybody understands? So always think of variables as p. Now, we're going to do one more example. What if Sophia has 2 pens, but I have 4 phones? Everyone cool with this? So Sophia has 2 pens and I have 4 phones. I'm going to make it F for phone. I know that that's not actually how you spell phone, but I just need to use a different variable. So Sophia has 2 pens and Marianne has 4 phones. Can I add those together? Can I say I have 6 pen phones? Can I say that? That wouldn't make any sense, right? So I just have 4 phones and Sophia has 2 pens. So all I would say if I wanted to add those together, all I would say is Sophia has 2 phones and Marianne has 4 pens. Sophia has 2 pens, Marianne has 4 phones. That's it. 2p plus 4f. So there's a couple of mathematical things that we've determined here. Let's go through them one by one to make sure everybody understands, and then we're going to do some examples. The first one is we can only add together the same things. We can't add f with p. So we said that you can only add like terms. Is everybody cool with that? Yeah? So only add like terms. And what I mean by like terms, remember how I said to think of variables as things, yeah? So you can only add the things that are the same. And you agreed, like you immediately noticed, no, you can't add phones and pens together. It's the same sort of thing. You can't add F and P together. That doesn't make any sense. Is everybody cool with that? Yeah? So you can only add like terms. And in math, a like term is just the exact same variables. Okay? So the same variables. So I just want you guys to get a bit of a feeling for what like terms are in math when you're dealing with things, because obviously when they give you a question, they're not saying like phones and pens. They're just giving you letters and you need to determine whether you can add them or not. So I'm going to give you guys some examples. I have some things here. Some of them are like terms. Some of them don't have any other like terms. Can I get you guys to just like color code them? So Sophia, if I want you to color code the first one in blue, do you see anything else that is a like term with that blue term? Anything else at all? Is there AB squared? Yeah, good. AB squared. Anything else at all? No. Okay, cool. So we're agreeing that if I say AB squared, that's like me saying apple banana squared. It's not the same thing as apple banana. Okay? So always think of it, it's really good to think of it as just like items. If you think of it as items, you're generally not going to make mistakes with it. Okay? Joseph, can I get you to tell me 5AB? Are there any like terms with that one?
Yeah.
What is it?
4AB.
Good. Awesome. And then maybe Sophia, can you tell me, does A have a like term?
3A.
Yeah, beautiful. And then does B and A squared B have like terms? No. So everybody understands the premise of a like term, yeah? So it's only the exact same variables. The numbers can change though. So the numbers in front do not have to be the same. It's just the variables that have to be the same. Everyone cool with that? So you can only add like terms. The second thing to remember is that you should add together the 1 in front of just a letter, because remember that letter counts for 1 extra, okay? We're now going to do a couple of examples. I'm going to put some easy examples on the board and they're going to gradually get a little bit harder. We're going to do those questions and then I'm going to talk a little bit about subtraction. Okay? So let's start there. Alrighty, so everyone just give these questions a go and then we'll go through them. You asked a pretty good question there. He was asking if like these two have to be in the same order or it's just about the variables being there. And it's just about the variables being there because remember what that means. Do you remember what BA squared means? It just means B times A squared. If I do something like B times A, pretend B is 5 and A is 3. Is 5 times 3 the same as 3 times 5? Is it? Yeah, it is. 5 times 3 is the same as 3 times 5. They're both equal to 15. So does it really matter the order that you multiply the variables in? Not at all. Okay?
Mm.
All right, Sophia, almost done?
I'm done.
Done. Awesome. Let's go through them. So, let's start with the first one. Maybe Joseph, can you go through that one for me, please?
What today?
10a. Perfect. Sophia, the next one.
9mm.
Perfect. The next one, Joseph.
5a plus 9b.
Perfect.
5xy plus 10x.
Yep, let me just take a look. So 5xy plus 10x. So 5xy plus... Now, is 8 plus 4 10?
See.
All good. So 12x, yeah? So just be careful with little things like that. And then Joseph, the last one for me, please.
3a to the power of 4.
Whoa, 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 whoa. Why are you doing to the power of 4? So be careful here. Remember what I said. Think about it. So pretend a squared b is like the number of cars I have or something. Like it's just a number that represents something. It should stay the same, right? You're not multiplying. Yep.
A squared b.
Beautiful. Does that make sense? So remember, with addition and subtraction, you're just adding together the number of items you have. Think of variables as items, okay? Now we're going to take a look at subtracting. And with subtracting, it's the exact same idea, okay? So with subtracting, you can only subtract things that are like terms. So addition and subtraction are almost exactly the same, okay? Now I'm going to add in some subtraction questions and we'll go through those as well. So you need to think with subtraction. It does get a little bit confusing. So I think what you're confused about here is like when you get the two separate answers for pq squared and pq, should you add them or subtract them? You need to check. So what we're going to do, I want you to remember that the operation belongs to the number behind it. So this minus is kind of in a block with the 2qp. And then this minus is in a block with the 3pq squared. And then this minus is in another block with the 6pq. So they all belong to the number, the operation belongs to the number behind it. Does that make sense? So what you're saying here is you're saying 10pq squared minus 3pq squared. What is that?
7pq squared.
Good. 7pq squared. And then you have a minus 2qp minus 6pq. What's that? So you're starting minus and then you're minusing even more. So what does that give you?
Minus 4.
Be careful. So
minus,
think about your number line.
minus 8.
Yeah, exactly. Beautiful. So it's a minus 8. So you just put minus 8pq. Do you get what I mean? So you always just, like, you don't need to think about do I subtract or do I add. You need to just think about the operation belongs to the number behind it, and then you just move around the blocks with the operation. Does that make sense? So that's for part G. What did you get for F?
I haven't done it.
Okay,
So
all good.
F,
Yep.
F I got 10 ST.
10 ST.
Yeah.
So 3 plus 2 is 5, plus another 3.
3 plus 2.
So what I'm doing is I'm just doing like 3 plus 2, which is 5.
Oh.
And then adding a 3, which is 8, and then minus 8, which is actually 0. Do you get how I did that?
I thought we did 3. I thought it doesn't matter what it is.
It doesn't matter. So even if you do 3 minus 8, think about what is 3 minus 8? It's negative 5.
Oh.
Yeah? So 3 minus 8 is negative 5, and then plus 2 plus 3 is 0. Does that make sense? So obviously if you had a calculator, that would be easier. But I think it's important that you do know how to do it mentally so you don't make mistakes in exams. Okay? And then can you just do part H for me, please? So the reason it's just 0, not 0 ST, is because what is 0 multiplied by anything? Because remember, when you write ST, you're saying times S times T. It's just 0. Doesn't that make sense? All right. Just do the last one for me, and then we'll finish up. So, yeah. Sorry. Go ahead.
I got 8m squared.
8m squared n squared.
Yeah, n squared.
Uh-huh.
Minus 1m n squared.
Cool. So 8m squared n squared. So for that, you did 12 minus 4m squared n squared, right? And then for this, you did minus 2mn squared plus 1mn squared, which is minus mn squared. Yep. Perfect. All right.
If I write minus 1n squared.
Yeah, minus 1n squared is fine. You can write minus 1, but remember what we said. When there's a 1, you don't need to write it. So you can just write minus.
Or I lose marking.
Not necessarily. Maybe in year closer to year 9, they would start taking marks away for that. In year 7 and 8, they don't mind too much. But I would say it just shows that you understand things better if you get rid of the 1. Okay? So we've covered adding and subtracting. I'm going to add some homework for you guys. And then next week we will continue with multiplying and dividing. Okay?